Welcome to the presentation on Level 1 Exponent Rules. Let's get started with some problems. So if I were to ask you what 2, that's a little fatter than I wanted it to be, but let's just keep it fat so it doesn't look strange. 2 to the third times, and dot is another way of saying times. If I were to ask you what 2 to the third times 2 to the fifth is, how would you figure that out? Actually, let me use a skinnier pen because that does look bad. So 2 to the third times 2 to the fifth. Well, there's one way that I think you do know how to do it. You could figure out that 2 to the third is 8, and that 2 to the fifth is 32. And then you could multiply them, and what? 8 times 32 is, let's see, it's 240, plus it's 256, right? You could do it that way. And that's reasonable because it's not that hard to figure out what 2 to the third is and what 2 to the fifth is. But if those were much larger numbers, this method might become a little difficult. So I'm going to show you, using exponent rules, you can actually multiply exponentials or exponent numbers without actually having to do as much arithmetic. Or actually, you could handle numbers much larger than your normal math skills might allow you to. So let's just think about what 2 to the third times 2 to the fifth means. 2 to the third is 2 times 2 times 2, right? And we're multiplying that times 2 to the fifth. And that's 2 times 2 times 2 times 2 times 2. So what do we have here? We have 2 times 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 2. Really, all we're doing is we're multiplying 2 how many times? Well, 1, 2, 3, 4, 5, 6, 7, 8. So that's the same thing as 2 to the eighth. Interesting. 3 plus 5 is equal to 8. And that makes sense because 2 to the 3 is 2 multiplying by itself 3 times. 2 to the fifth is 2 multiplying by itself 5 times. And then we're multiplying the 2, so we're going to multiply 2 8 times. I hope I have achieved my goal of confusing you just now. Let's do another one. If I said 7 squared times 7 to the fourth, that's a 4. Well, that equals 7 times 7, right? That's 7 squared, times, and now let's do 7 to the fourth. 7 times 7 times 7 times 7. Well, now we're multiplying 7 by itself 6 times, so that equals 7 to the sixth. So in general, whenever I'm multiplying exponents of the same base, that's key, I can just add the exponents. So 7 to the 100th power times 7 to the 50th power. And notice, this is an example now. It'd be very hard without a computer to figure out what 7 to the 100th power is. And likewise, very hard without a computer to figure out what 7 to the 50th power is. But we could say that this is equal to 7 to the 100 plus 50, which is equal to 7 to the 150. Now, I just want to give you a little bit of warning. Make sure that you're multiplying, because if I had 7 to the 100 plus 7 to the 50, there's actually very little I could do here. I couldn't simplify this number. But I'll throw out one to you. Just if I had 2 to the 8th times 2 to the, let's say, 20th, well, we know we can add these exponents. So that gives you 2 to the 28th, right? What if I had 2 to the 8th plus 2 to the 8th? This is a bit of a trick question. Well, I just said if we're adding, we can't really do anything. We can't really simplify it. But there's a little trick here, is that we actually have 2 to the 8ths, right? There's 2 to the 8 times 1, 2 to the 8 times 2. So this is the same thing as 2 times 2 to the 8th, isn't it? 2 times 2 to the 8th, that's just 2 to the 8th plus itself. And 2 times 2 to the 8th, well, that's the same thing as 2 to the first times 2 to the 8th. And 2 to the first times 2 to the 8th, by the same rule we just did, is equal to 2 to the 9th. So I thought I would just throw that out to you. And it works even with negative exponents. If I were to say